Hello students, welcome to the online video session of Academic World School Bimitra. I am again here for class 10th physics and today's topic is AC generator. Today we will be studying about generator. It is a continuation topic of the chapter magnetic effects of current. So students, requested to take out your notebooks and note down all the things which are being taught from here. In the previous session we have studied that whenever a coil moves in a magnetic field, then there is a induced current produced in the coil. Now, production of current if it is being able to produce by simple movement of coil in a magnetic field, it's very interesting. Therefore, we can produce as much current as much we want by simply moving. For that gives the idea about how to produce electricity, and it is the basis on which we are able to produce current. From where the current comes in your house? Surely you must be wondering, it comes from the electric poles. It's actually coming from some power plants and they are producing the electricity there. It may be hydel power, it may be thermal power, or it may be a gas station. So from wherever it is coming, the current, it is coming in the form of alternating current. Can you use it the same way for using it in your cell mobiles? No, you need one adapter. So what is different? One adapter and one main supply. Their difference is in the type of current. There are two types of current. One is called direct current. Direct current you obtain it from battery. A battery is a source where it has a fixed positive and negative potential, plus and minus. You must have seen, if you take a pencil cell, then there is a positive terminal and there is a negative terminal. So that is the direct current. Direct current never changes its direction. Its one terminal will always be at high potential and the other terminal will always be at the lower potential. So current continuously flows in one direction. That sort of current is known as direct current. But the current which you get from the supply, main supply in the switchboard, that is having reversing potential. The terminals are not fixed. The polarity is not fixed. The direction of the current continuously changes. So we have got two types of current, alternating current and direct current. I have made column and to try to show you what is the difference between the two. Alternating current, and simple language you can call it as AC. So AC is the type of current which changes the direction after a fixed interval. In India, the direction of current changes at a rate of 50 Hertz. 50 Hertz. What is the meaning of this 50 Hertz? It means there will be 50 cycles in 1 second. And let me explain you what is cycle. This kind of will be called one cycle. So this from here, it comes here. It is one cycle. So in one cycle, there are two times change of direction. Frequency, if India is 50 Hertz, that means the direction changes 100 times. So 100 times. Moreover, the AC is used to run the heavy machines like washing machine, motor, air conditioner, etc. Even in factories. Okay. Whereas the DC doesn't change the direction. The direction of DC remains fixed. You are using it in your wall clock. You see where is the plus and minus, and then you insert the cell. So when you insert the cell, it constantly gives current in one direction only. That type of current is called direct current. So alternating current and direct current, they are the two different types of current. Direct current is used in small devices like as Walkman, watches, cassette players, toys, etc. So simple smaller things are using these direct current, whereas the heavy appliances, they make use of alternating current. Please note it down. The frequency, you must memorize it. For India, the frequency of AC is 50 Hertz, which means the direction changes 100 times in 1 second. 100 times in 1 second. Okay. So that is to remember. So as I told you, AC and DC, they are the two types of current which we can use in different devices. Now the important thing is, how do we produce the current? As I told you, the current can be produced by electromagnetic induction. If a coil moves in a magnetic field, it produces induced current. This is the principle of generator. The principle of generator, write down. A generator is based on the fact that when a coil moves in a magnetic field, then an induced current is formed in the coil. This is the principle of the working of a electric generator. So what is the principle on which the generator works? The generator works on a simple principle that whenever a coil will move in a magnetic field, then there will be a production of the induced current. Okay. It is according to the right hand, Fleming's right hand rule. It uses Fleming's right hand rule. So I have taught you in the previous lesson what is Fleming's right hand rule. The Fleming's right hand rule, thumb is in the direction of the motion, the forefinger in the direction of the magnetic field, then the middle finger will give you the direction of the induced current. Okay, so let us see how the generator looks like in block diagram. Okay. See, generators may be different in shape and size. A small generator you must have seen outside any shop. That is very small, portable. It's very small, less than 2 feet and weighing only 10 to 15 kg. But if you need to produce current on a large scale, in that case the generators are very bigger, huge, and they are installed in some dam or thermal power station. But basically the construction of all the generators is similar. What are the main parts are this, like this. In a generator there always will be one pair of block magnets. Now this N and S, they are the two block magnets and they are used for producing a magnetic field here. Okay, so magnetic field will be produced by any magnet. Then there will be a armature. Armature is a core on which the coil is wound. Coil, the wire, insulated copper wire is called coil. So insulated copper wire will be turned all around it. Here to explain you, I have simply taken one round. Okay, this A, B, C, D, one thread, but in practically there will be enormous number of threads. Okay. Now this ABCD is a rectangular frame on which the wire has been wound. The ends of this one, they are connected to the rings R1 and D is connected from inside passing to R2. Okay. Now this R1 and R2 will be getting electricity, or you will get electricity at these 2 points R1 and R2, and from here you have to draw it out. So for that I have brushes. This is called brush. Brush is, there will be two brushes, B1 and B2. What is R1? These are the slip rings. R1 and R2 are slip rings and B1 and B2 are the carbon brushes. So brushes are there, rings are there, one rectangular frame armature is there, and a pair of magnet to produce strong magnetic field. Okay. Now, unless you move the frame, you cannot produce electricity. What is the principle? A coil moves in a magnetic field. So I need to turn this ABCD armature in this one. How I will move? I will move it clockwise. I will be moving it clockwise. For you to explain it better, I have taken one armature diagram. You can see it is exactly like this. A, B, C, D. Okay. So now here ABCD is there, and by one handle mechanism I am trying to rotate it. Clear? So now we will see how it will work. When ABCD will be rotated clockwise, this will happen. The AB will go up and CD will go down. See here, AB is going up and CD is going down. Okay, so here when AB goes up and CD goes down, in that case I will apply the Fleming's right hand rule. The magnetic field is from north to south and AB is going up. So what is the direction of current? The direction of current in arm AB is from A to B, and then the CD is going down. When this CD is going down, the direction of the current is towards U, from C to D. Okay, so let's write the working. Working of generator. When the armature rotate clockwise, then AB goes up and CD goes down. The direction of current is A, B, C, D. Okay. So the current will be coming from here A, B, C, D, and if I connect it externally, I will get current from here. So B2 will be positive and B1 will be negative. So in the first half, when AB is coming up and CD is going down, at that time this ring 2 is positive. I have made it red, and ring 1 is negative, like this. Now this CD has come on the left hand side. So after the half cycle, what happens? It turns like this, and now CD comes here. C, okay. So after the rotation, what has happened? AB has gone on the other side and CD has come on this side. So now the direction is this one. Now when DC arm will go up, the current will flow from D to C and B to A. So in next half cycle, CD goes up and AB goes down. Therefore, direction of current becomes D, C, B, A. See here, earlier AB was coming up and CD was coming down. So current was from A to B to C to D. So after half cycle it has turned, and now this D has come, CD arm has come on the other side. So when now CD will come up, the direction of current will be from D to C to B to A. So it will be D, C, B, A. Okay. So D, C, B, A. At this time what happens? The D is connected to B2. So B2 will now become negative potential and this one will be positive potential. So if you are making a graph between the current which is drawn here, the current will be flowing like this. Okay, this is AC current. It is AC. Here you will get alternating current. The type of current which you will get here is alternating current. See, A, B, C, D. Earlier AB was coming up and CD was coming down, and the direction of current was A, B, C, D. Therefore, ring 2 was positive and ring 1 was negative. After half cycle, what happens? The CD comes this side and CD is going up, AB is coming down. So the direction of current becomes DCBA. So now this time this R1 becomes positive and R2 becomes negative. So the polarity of the terminal is constantly changing in every half cycle. This kind of current leads to alternating current. It will be one time flowing this side, then other side, then other side, then other side. So I hope you understand what is AC and what is the principle of generator and working of generator. I will recapitulate this whole thing again. Say, in a generator, the main parts are a magnet pair that will produce a strong magnetic field. Then there is a armature like this. Armature will have 4 corners. You can say ABCD. Okay, A, B, C, D. and the two ends are connected with rings R1 and R2. So in the beginning one becomes positive, the other one becomes negative. Okay, so when I rotate the armature clockwise, AB goes up, CD goes down. So it rotates. In that rotation, these two rings are also moving. They are called slip rings. The reason they are just slipping over the brushes. Now what are brushes? Brushes are having contact on these rings. See, this will be in constant motion. So we need to draw current from here. For that purpose, we will be having these brushes. The brushes B1 and B2 will be drawing current from these two rings. That is, they are working as a terminal. Okay. Now when the current will be drawn from here, that polarity will be maintained at these two terminals. B2 will act positive and B1 will act negative in the first half cycle. When it rotates, now CD has come up on the left hand side and AB has gone on the right hand side. This way, what happens now? AB will go down and CD will come up. This time, this ring 2 will be negative and ring 1 will be positive. Because of this constant changing of polarity, we get a current which is reversing its direction after every half cycle. This kind of current is called alternating current. Alternating current, this diagram I have made here, it is the diagram of a AC generator. If you want to convert, make a DC generator, then simply you have to change these rings. See, in motor I explained you about two half rings, cup shaped. Okay, so if you are using that, that half rings, you will get direct current. Let me draw that also. Instead of these two complete slip rings, if you make use of those C-shaped split rings, okay, and then you connect it with the brushes. In that case, you will constantly get one terminal as positive and the other terminal as negative. This will be a direct current generator. So what is difference? Commutator. How can you convert an AC generator to DC generator? Okay. How can you convert an AC generator to DC generator? Answer will be by changing the commutator. By changing the commutator of the AC generator, it can be done. Now always remember, in AC generator what we have? In AC generator we have slip rings, whereas in DC generator have split rings. So this is by which you can convert AC generator and DC generator. So my dear students, you have understood the generator, types of current, what are the difference in the two types of current, AC and DC, and you have also understood how can you convert the AC generator into a DC generator or vice versa. Please download the homework assignment from the ERP and submit it as soon as possible and learn these generator. Practice the diagram. Diagram is very essential, and label the parts which are of the generator. Thank you.